Hello everyone, thanks Mike for the warm welcome, and thanks for having me here at React Native Europe. I'm really excited actually today to talk with you about kind of different concept and different type of talks I usually do. Talk is more conceptual and more like to understand how the mental process goes of animating things. So I called it Demystifying complex animation creation process in React Native, but before I start, a little bit about myself. So this is my fancy logo, which is actually was done by just taking code from VS Code and just putting it in Sketch, and somehow it worked as a logo. So I'm an independent consultant. I do workshops, consulting for various companies in all these fields. The left side was Twitter handle, right side my website. So say hi. The question that I want to ask, why do we need to animate? Some people say, well, because I can. I want to talk why, and I actually want to talk about you, no, about us as humans. So we are humans, are visually driven creatures, and basically this slide would be really awful without this cool picture out there, because we are visually driven. And not only us as developers, we're also users of other apps or of our own apps. We all are visually driven. So again, why do we need to animate? The obvious thing is we want to make our app stand out. But this obvious thing sometimes leads to bad animation. Sometimes it leads to taking an app to extreme, doing some crazy animations, and doing some things that distract user actually. Ultimately, we want to provide visual hints for our user how to process our app, how to understand the app, how to navigate through the app, and ultimately define a story of your app. So Yanni told in the morning about caring about user. You want to care about user also by defining the actual story that you tell your user. And two other things that you want to do is to reduce cognitive load of the user and reduce cognitive friction. So what is cognitive load? So there was a theory in 1980 invented by John Sweller, psychologist, and yeah, I'm talking about psychology. You know what I'm doing, but yeah, let's try it. So he talked about the cognitive load as with the following example. For example, if you have a square that is written on a piece of paper, and you look at this square, your mind understands instantly this is a square, because it's presented in visual medium. But I also can present the square in verbal medium. So if I say I have a line, vertical line, pointed up, and in the end of this vertical line, I have a perpendicular line, 90 degrees to it, go with the same width. And in the end of this line, I have another line perpendicular to the second line and parallel to the first line. You know where it goes. So in the end, you will understand this is a square, but it will take much more time to process this. So the same is with app without animations. You may may want to tell a story with your fancy screens, but if you don't provide visual feedback, you will actually bring cognitive load on the user. Sometimes you do animations in your app, and sometimes these animations are really cool. You have like flying messages from all over the place, like something really, really cool. Designer created a piece of art, and you implemented it. But there is a problem. You basically created a cognitive friction, because we as users, we already know experience that work. We know that if we have a chat, probably message will fly from one side or other side. We don't expect message to explode into tiny pieces, connect into one, and present in the middle of the screen. That will look wow, but it will be different, and basically it will create cognitive friction. So your UI should be predictable. You need to predict the flow of the app. You need to you need user not to think about an app, but just act on an app and navigate between screens. Your UI should react fluidly on user actions. You don't want to delay things, you want to react instantly, and animations that you give, you want to give them really smooth, but not overcomplicated. And that brings me to another topic I want to talk with you about animation types. So when I'm talking about animations type, that's not what the picture says. I won't talk about Disney or drawing animation or stuff like that, or history of the thing. I will talk about different animations that we can differentiate in user experience on mobile, or in general, on web it works too. So we have state-driven animation, and we have really, really ugly animation there of a model, right? So you may say, probably you see that it's ugly. But if you think about it, okay, it's animated, fades in, fades out. What's wrong with it? Consider it's not a model, consider it's more complicated animation. For example, if you have a form and you want to post a message and it fades in when it opens the form and it fades out when the form is closed. So the problem there is that you're leaving your users in the dark. Your users don't know what to do. Like, they don't know what happened. Like the form was dismissed, or the message was actually sent, or like what happened in the app. So I like to call it, you basically try to shoot in every direction to try to get attention of user. But what we can do to change that? A little change will make animation different. So when model is opened, it flies from the right corner, and when it's closed, it's dismissed in the same corner. So these animations are called action-driven or functional animations. So consider this cool animation that I found on Behance. This animation is driven completely by user action, and it reacts differently by different user inputs. These kind of animations that you want to create this up. Maybe this one is actually like overcomplicated, but you got the idea, I believe. So you need to react to user actions, and based on this action, do this animation. But that's not all. There are also micro interactions. And if you take a WhatsApp, for example, and open it, you probably will, and will search for micro interactions, you will probably find 10 or 20 different micro interactions you haven't seen before. For example, take a look at the interaction here with the inbox. So at the first glance, you see on the number change and messages appear. But if you look closely, you see the number is rotated, messages appear from below, and it actually behaves different if a message was sent, if a message was dismissed, discarded, stuff like that. So these type of animations are really cool, but not because user pay attention to them, because your UI looks more fluidly to the user. It looks more natural, because we are living in the real world, right? So we are used to physical forces, we're used to physical feedback. The same, like if you click on a button, the button will react somehow, like if it's a physical button. So we want to bring the same behavior on mobile or web or any medium, basically, because we want to bring user attention to something they are familiar with. So there is a saying, magic is both in the details and in the performance. It's by Darrell Fritsky, famous magician. And the thing is, like, we are doing this magic, right? But how we structure our app, how we structure animations is basically the performance. And that's basically how we make app better. So, ladies and gentlemen, I introduce you a React Native College of Wizardry, and I will tell here a tale of a young magician called Merlin. Why magic? Because there is a saying that any sufficient advanced technology is distinguishable from magic. So, if you travel back and show React Native app to some medieval king, so you probably will be either burnt or you will be considered as a magician. So all you are magicians, but let's talk about young Merlin. So young Merlin is a really good magician. He already knows about animated, and he knows about Lottie, and he even knows about reanimated. He heard about that in the previous talk. So young Merlin gets a design from proud artists. Artists did an amazing job creating the state of art. It's the best portfolio work that he will probably, now he'll move to a different company and will get more money for his work. So Merlin approaches the designer and asks him, how did you do that? And he gets, it's magic, right? So it's magic, that's cool. But let's take a look what designer gave him, for example. And yeah, why should it load? I probably need to exit full screen. Yeah, sorry about that. That's probably what happens with animation talks today, right? No, Wi-Fi is okay. If it's not, I will probably find video somewhere. Actually, you know what? Let's just run the app. It's already running. Let's just run the app. So basically, it says something like this. So notice here there are like micro interactions, like these ones bouncing, stuff like that. If he clicks, he gets to the screen and he gets a bunch of magic spells, well, like parallax scrolling and stuff like that. And Merlin is sort of in shock, like what's happening here, like how he's supposed to even start doing that. So how he even starts. So there is like divide and conquer term, right? So in order to create these like fancy animations, as here or like in any level of complexity, you basically need to separate animations to some kind of layers. First of all, first thing that we notice is micro interactions. We've seen that our magic spell cycles or whatever it is, just Google images, they are bouncing a little bit. So we know that we change some kind of properties on them, right? We also, we've seen that there are action-driven animation. When we click on the circle, we get to the other screen and we have like parallax scrolling, which is also action-driven. Like scrolling right as one thing, left the other thing. We've seen screen transitions here because we're navigating between screens, and we saw gesture animations and on-scroll behaviors. So first of all, what you start with is basically, specifically with this animation, is differentiate different style types. So here you have several style changes, and you already know animated and reanimated. You heard about that. So I won't go deeper in the API. We'll look at the code later on. But the thing is, if you separate these styles, you will be able to comprehend the whole complexity of animation. So we have scale changes. That's, we see the first thing. We have these magic circles bouncing back and forth. We had opacity changes. It was a little bit when changing the screens, but there were some opacity changes. We translated X and Y of our magic circles, right? So that's for the styles. We also seen gestures, but don't confuse gestures and scrolling behaviors, because we've seen parallax scrolling, right? And the first thing you may think of, okay, it's like gesture-based, I like move right, left, it's parallaxing, but sometimes people confuse scrolling on scroll behaviors as gestures, so don't confuse that. So we didn't have any gestures behavior, had on scroll behaviors. So let's see the actual code and how we basically structure the whole thing. So I use transitions and by using React navigation, fluid transitions, but we had also amazing talk on the first day about transition. We had enough talks about navigation and transitioning. But here I use React navigation fluid transition because we have concept called shared elements here. We have different screen, we have the same image that it changes from one screen to another. Well, in fact, it's not the image changes from one screen to another. It's in fact on one screen image animated in one way, on the other screen the same image animated in a different way. It's just this library calculates the position of the image on the first screen, and on the second screen it animates it to its supposed place. So here I declare fluid navigator, and I have cover, alchemy, spellbook, mage profile, which is actually alchemy is sort of empty, and mage profile I haven't had time to create mage profile. Maybe because Merlin is young, I don't know. Maybe he's a new user to an app, but we'll see how he will react. By declaring transitions, I declare a shared element. I take the transition out of React navigation fluid transition, and then I define my image with some width and height, and I actually rotate it. So let's check this in the app. So when I click on the image, it's rotated, right? So it looks like the image was transitioned from one screen to another, but actually it's two different screens. In addition to that, I had parallax scrolling. So parallax scrolling, first of all, when we see this type of thing, we need to think which direction it goes. So here we saw that it's horizontal, obviously, and we want to snap to a side, so we enable paging in our scroll view. We also don't want to throw events all the time, so we want to enable some kind of throttling, and here I enable it on 20 milliseconds, which was just like, it can be 16, it can be anything you want. And then I pass animated event to the on scroll. So animated event works in the following way. The into animated value gets the X basically that you declare here. So in a nutshell, right? So what happens, animated value is like new animated.value, and whenever I scroll, I get the actual X of my scrolling inside the inside animated value. Then I need to declare style. The style in style declare transform, and I interpolate. I have some kind of helper, get interpolate function, and I pass animated value, index, and image length. The reason for that is because this horizontal scroll is going out of screen with all the images, right? And I want to know on which index I'm currently instead of for the interpolation later on. And I need to know the whole width of the image strip, basically. Then the scrolling, the animation of image and the image itself is basically animated image. You pass a regular image source and you pass your animated style. This is the get interpolate function. So in get interpolate, it gets a bit more complex. So I have some calculations here for input range and output range. But the idea is the following. When I'm in the screen, because I have paging enabled, if I'm inside the screen, I don't want to interpolate. I want to stay on the exact place. But when I move the image, I want the second image to move a little bit behind it. And when I snap to place the other image, it moves behind the first image. So let's see how it looks like here. So if I scroll here, you see the image is moving a little bit, like parallax here. And if I move back, well, basically when I move here, the first image is translating and the second image is translating. That's how parallax here works. So that's what makes it happen. And a really important thing when you're interpolating on values, it's really important to know that you need to extrapolate at some point, especially if you're dealing with, like you're interpolating not on the whole range, because it can lead to weird bugs. For example, a really known example, you just can Google this example, you'll find a bunch of articles on that. Twitter header, the common problem there when people animate it is the profile picture goes beyond the screen, and that's because of not providing extrapolate parameter to interpolate function. So gestures. With gestures, we use pen responder. No, if we don't want to end like that. Why is that? Because pen responder is actually this hell of sorts. So pen responder works in JavaScript, and you have JavaScript bridge, JavaScript bridge, JavaScript bridge. That's why there is React native gesture handler and reanimated. So reanimated, continuing from what we left from the last talk. So reanimated is not only cool API, a cool library that you can use. It's similar to animated in terms of API. Reanimated works natively, meaning if you use reanimated and React Native gesture handler, and you use it for gestures, none of your gesture events will go to JavaScript realm during your dragging or whatever you do with gestures. So if you use both, you'll basically have native performance and native dragging capabilities. So there are a bunch of examples of reanimated and gesture handler, and I think what's with the time? Okay, cool. So cool, I have time. That's cool. So what about really complex animations? We've seen Lottie with clouds on the previous talk. And Lottie is amazing, actually, but especially if you want to create these sort of animations, right? So probably you cannot create. Well, you can get creative and try to do it with animated or reanimated. Please, if you do it, tweet and mention, so I will see how you did that. Because so Lottie is really good, and it works. Basically, React Native Lottie is a wrapper for the native Lottie library, and it loads JSON and it draws JSON. But it's really good, but there are some kind of monsters in Lottie, and lots of people probably that dealt with Lottie seen this in various apps. Sometimes models are like JSON exported animations, basically, they are too big. Sometimes they're not defined correctly, and sometimes it just can crash you up. So, like in 50% of cases, I would say, unless you have a good designer that knows what he's doing and export these custom animations. So, if you go to Lottie files, which is this way. Oops. No, it was a spoiler. I will show you later all the websites. So it's lottiefiles.com, I believe. It's a resource for various Lottie animations, various JSON, so you can download that, play with it, crash half of your apps, and yeah, try to understand which is better. Also, it has some limitations, like it cannot deal with 3D content. It has various problems. There is troubleshooting guide, but it's like one pager. So, the takeaways that I want you to take from this talk and now are basically animations are not that scary. That's the first one. And it might be easy to say animations are not scary, but when you get the actual animation from designer, you may be spooked by the amount of things there. But you need to remember that you need to take your animations and just separate it to layers, separate it to different styles, different concepts, if it's gestures or if there are on-scroll behaviors or stuff like that. So beware of state-driven animations, and you will get those, you'll probably get those from designers. So interact more with designers and understand what they try to do, because maybe they unintentionally create a state-driven animation which they think are obvious for the user what to do, and it's not obvious for you what to do. And actually there can be, also listen to your QA, because sometimes it's obvious for you, it's obvious for designer, but it's not obvious for QA, and that probably means that you're in the realm of state-driven animations. Tell a story in your app, because user is really important. I know everyone hates when we get like bugs or issues on our apps, and some people blame users, but actually user gives you the indication of how good your app is, in if it's worth it at all. Because like there are like millions of apps out there. I don't know the exact number. I'm just so there are like lots of apps out there, and you don't know what might catch user attentions. So don't overcomplicate things. Sometimes when you getting complicated animation, you also have like this urge to create it, because it will also improve your portfolio, right? Or it will be a challenge for you, and it looks cool, but it's not necessarily a good thing for an app. Reduce cognitive load and reduce cognitive friction for the user. So stick to animations that work. I'm not saying like don't be creative. I'm saying if you have animations that work, maybe change them a little bit. Maybe talk to designer about this concept and change subtle things in animations to still make it recognizable, but don't cause cognitive friction, basically. And stick to working practices and experiences. So there are a bunch of apps that works, and you not necessarily need to create something totally new in terms of UX. You can create something totally new in terms of business logic, or in terms of general experience, or even like different layer of different audience or different users. So thanks for having me here. Thanks for being there. And if you want to connect me on Twitter, that's my handle and my website. Thanks.